Okay, this is problem 4-44, and what's going on here is there is a floor panel on top of 6 beams, and all the beams are resting on top of that big girder. In order to solve this problem, we split up the floor at each one of the beams, solved for the forces that are in those beams individually, and then once we knew the forces in the beams, we knew all the forces that were pushing down on that girder. And from there, we drew the free body diagram of the girder itself and made a shear moment diagram from it.
Okay, so on the board here, we've already drawn out what the free body diagram would look like for problem 4-44. Here in this shaded region, we have the girder AB, and then each of these vertical lines right here are the beams that rest on the girder, and then this line right here we have represented of the floor plane. And as you can see, they're all 5 feet spacing, and then we have the single 4 kip load there and the 2 kips per foot load right here. And if we move on to the free body diagram of the beam that we have over here, you can see that we broke up the middle of the beams and we assumed that we had positive vertical forces at beams A, B, and C, D, E, and F. And we also have equal and opposite forces pointing in the downward direction on the girder, which are expressed right here by the arrows pointing downward. So we know that what we have to do to solve this problem is first solve for the numbers, or for the forces in the vertical direction for points A through F. And then as soon as we do that, we'll be able to go and take those forces and display it in our free body diagram. So if we move on and if we take a cut, for the first thing we do is we take a cut right in between numbers D and E, and we'll have a free body diagram A, C, D as expressed in this drawing right here. First, what we notice from this free body diagram is that there are zero forces at A, and this is due to the fact that what we do when we analyze this problem is we break it into sections. So if you look at only section AC, you can see that there are no vertical forces affecting the support at A. So we know that there aren't going to be any vertical forces acting on point A. Whereas if we looked at point C through D, we know that the 4 kip load here will have to be taken in part by the beam at point C and in part by the beam at point D. So to solve for the numbers C, or the vertical forces at C and D, we first take the moment about point D. Now you can take the moment at point A, or you can take the moment at point C or at point D, but you can't take it at A because we need to get rid of one of the forces that we're trying to solve for. So we arbitrarily chose to take the moment at point D, in which case we also had the positive direction being this way, as expressed right here. And so we said that the moments about D is equal to our vertical direction CY, which will be in the negative direction, and it's also 5 feet away. So the negative CY at 5 feet, and then we added on the 4 kip vertical load, which would be in the positive direction because it's going with the positive direction moment that we have assumed, and it's acting at 3 feet away from point D. So from this equation, if you do the math, then CY turns out to be 2.4 kips. So once we found that force CY is equal to 2.4 kips, we next sum the forces in the Y direction, and we go that CY plus DY minus the 4 kips is equal to 2.4 kips plus DY minus 4 kips. So then we have that DY is equal to 1.6 kips.